All right, Tuesday evening. Thank you all for coming. We're gonna get started. Thank you for spending your evening with us. I know I'm between dinner and probably a few drinks. Tonight is gonna be magical because you are essentially going to magic school for security. We are gonna talk about security alchemy and how AWS uses math and automated reasoning to prove security. My name is Bridget Johnson, and I'm the GM of IAM Access Analyzer, and I am happy to be here with Neha today. And before we get started, before we go to school, before we go to our classes and look at our rubric, we're going to start with a story.
Hi, everyone. It's great to be here in person. My name is Neha. I lead the automated reasoning and identity team. And I'm going to tell you a little story, as Bridget said. I joined AWS about 6 years ago. And before that, I used to work at NASA Ames Research Center. And my job there was to develop automated reasoning techniques and algorithms to develop high assurance of correctness and security for aerospace systems. Because having the highest level of correctness and security was critical to all the systems we worked in. So then when I came to AWS 6 years ago, my charter was, hey, do the same for cloud systems. And the question I was asked was like, can you apply these techniques and algorithms for proving the correctness of cloud configurations, cloud design, cloud implementations? And I'm like, yes, absolutely we can do it. And a lot of people looked at me funny, and they were like, that doesn't sound right. And Bridget was one of them.
Sure was.
Like, she looked at me funny. I remember that look. But we were like, okay, we can get started. So what should we start with? We developed this internal tool called Zelkova, which was about the analysis of access control policies. And we applied it internally to detect misconfigurations of resources. One check we applied at a broad scale across all AWS resources internally was, is the bucket public? So in the true Amazon spirit, when we find something that worked internally, we make it available to our customers. And this talk will tell you about the 6 years we've been on and how we've developed services and features to help customers raise their assurance in security, and we'll tell you the secrets behind them.
Oh, secrets. Love secrets.
Yep, secrets.
All right, so here's your rubric. This is the next hour. These are your classes. So we're going to talk about higher security, and that's why we're all here today, raising the bar for security. Then we're going to take a trip to the apothecary, because you got to get some school supplies for your magic class. Then we'll dive into automated reasoning and comprehensive analysis, and you'll take that and bring it to your transfiguration class. And that's where the secrets really come out. Then we're going to take all the foundations that you learn, and we're going to brew some potions, so you're getting better. But my favorite part is at the end, where we have the security charms. And that's where these are the charms that you can bring back to your organizations. And these are also where the demos are, which I'm going to attempt to do live today. So this is your rubric. Hope you have some fun. Higher security. This is why we are here. AWS always prioritizes security first. And so our customers tell us they love the security controls, the robust controls, the comprehensive controls to secure your cloud infrastructure. And we have a growing number of security controls. We have network controls. And this is all about controlling access to your inbound and outbound traffic. We have my favorite, which is access controls. All those policies and permissions that grant who can access what, specific actions with specific resources under those specific conditions. I am talking all about that tomorrow morning if you all want to join. And then things like data encryption. So there's a lot of security controls, and they're applying to all of your cloud infrastructure and your environment and your systems. And here are some examples. We have service control policies. You can restrict access to specific actions, resources, and under conditions across your entire organization or organizational unit, or even just a specific account. That's all about restriction. Then you might want to grant access because, of course, you want to allow Neha to look at pictures of Pickles. Pickles is my horse, by the way. You will hear about him a little bit today. And that's where you use identity policies and resource policies. You have your endpoint policies, which can allow who can access your endpoints. And then you have block public access, which does just that. And you can enable it for Amazon S3. And I think it's a fan favorite over here.
Yes, I love BPA. And what do I love about BPA? It's simple. When we launched BPA, I truly believe it was a watershed moment for security because you can go with a single click, turn on and block public access to all your buckets in an account. It's simple, it's orthogonal to all your existing access controls, and it's declarative because you just say, turn it on. And I truly love it, Bridget.
I know you do. I've heard a lot about it. Okay, I got it. All right, and then you have some other service-specific controls. But with all those controls, you have access paths of a system. And there can be quite a few of them. And this is good because you want users to access things like pictures of pickles. Or you might not want people to access things like your critical systems or your critical algorithms. And so with that, you're looking at all of the access paths of your system, and you want to ask, is there a path? You want to determine, is there a path? And this can be kind of hard because there could be a lot of paths to explore. So how do people do this?
So people have done it in the past with a lot of testing. You have unit testing, integration testing, pen testing, and canaries and fuzzing, but you also have AppSec reviews and code reviews. So all of those techniques are necessary, but not sufficient, because they give you a partial view, not a complete or a comprehensive view.
Well, all that work sounds a little bit uncomfortable.
It is very uncomfortable.
All right. But couldn't you just write a Perl script and parse through the graph that's on the screen?
Bridget, nobody writes Perl scripts anymore. I've told you this so many times. But I get your point. You could write a Python script or a Ruby script to brute force it. Just brute force in exploring and enumerating all possible paths in this graph. But that would take you several lifetimes of the sun for any system that is remotely realistic that is deployed in production.
Well, you always told me that you wanted to go to space, so you can just, lifetime yourself to the sun, to space.
I do want to go to the space, and which is why we're bringing the future to you now, today.
All right. So you're telling me automated reasoning can help with
Yes,
that?
the future is here.
Okay. All right. I believe you, maybe. All right. So before we learn about how we determine if there's a path with certainty, you all need to go to the apothecary. So this is your list, your school supplies list. You might not know what all of these are yet, but you will learn, but you need them anyway. Universal statements, you will find those in the comprehensive analysis section. Start pondering what those might be. You need your AWS security controls and what those behaviors are. You will need your security configurations and all the resource metadata, so all these knobs that you're turning. You will need some transformer potion. You will need a solver potion. You'll need some compute, and just to make sure that you don't forget anything, please make sure to get your automated reasoning textbook. Okay, so now that you have your school supplies, we are going to start with automated reasoning and comprehensive analysis.
So all of that sounds a bit magical. And today I am going to talk about what is the secret behind the magic. And spoiler alert, it's just math. It's not magic, it's math. So welcome to Automated Reasoning 101. There are three main parts that you have to know about. The first part is collect, the second is transform, and the third is solve. Once you do these three things, you get to comprehensive, provable answers. So the first part is knowing what AWS resources or controls that you want, just the types of controls. And then you have to get their configurations. Are they bucket policies, SCPs, identity policy, network controls? And then you want to have universal statements. What is it about them that do you want to check? Bridget may want to say, hey, I have these vacation pictures that I only want Neha to see because Neha's my friend. But I have these pictures of pickle that I want everyone to see. So that's the type of universal statement. Now, as you view these three things, you have different aspects. And the different aspects depends on the lens you have. If you're just a muggle, since we're talking about magic, we got to talk about muggles. A muggle may have a question. Hey, who has access to what? Like, they may just say, can Neha view pictures that Bridget has, vacation pictures? And what are the configurations? Are they comprehensive? But a scientist may just add a bit more rigor to that statement. They may say, hey, here's a property that I want to prove across all possible paths. And if you're a security alchemist, you may say, I want to make a universal statement that explores the universe of possibilities and gives me provable answers. So you see, there isn't a lot of difference between each of the three things, but it's really about the lens you apply. Now, I've talked a lot about universal statements.
What are those?
What are those? Yes, what are those? A universal statement is something that always holds true. You've learned this in school. Who remembers the square of every real number is non-negative? There is a word here that makes it universal. Every. You can even say it differently. The square of each real number is non-negative. The each is also universal. Here's another way. The square of all real numbers is non-negative. The all. So the words like every, each, all, they denote a universal statement. How do we know it's universal? Because we have a mathematical proof about it. We're not testing different real numbers to see if their squares is non-negative. We know it. How do we know? Because it has a mathematical proof. We studied it in high school. Same thing about Pythagorean theorem. How do we know?
I do remember this.
Yeah, exactly.
Right, there you go.
But now you're not fuzzing the different triangles. Are you trying to look for a canary that can generate a triangle where the Pythagorean theorem doesn't hold? No, because we know we have with mathematical certainty that it does hold. And that's the level of rigor and certainty that we want to our security configurations. And that's why we are using universal statements about the security and using mathematical reasoning, which we also call automated reasoning, to prove its correctness.
All right, let's bring it to the cloud.
Great. So what are some examples of customers wanting universal statements? All my data at rest is encrypted. That is a perfectly valid universal statement. There are no S3 buckets in my organization with public access. No credentials are logged in plain text. Or there's just no deadlocks in my code. These are all examples of universal statements.
That sounds very nice. I'm sure the lady in purple with the hat and the umbrella would be very happy if all those were true.
Not only the lady in the purple, all our customers would be very happy with these universal statements.
All right. And to get to those universal statements, you need controls. So with AWS controls, you have fine-grained security controls, and they behave in a defined way. So you might have a deny statement in a policy. I'm hoping y'all have written a policy. And that means that access is restricted to the action resource under the specified conditions. Even if there's an allow, if there is a deny that matches, it will always kick in. Or you might have an assume role policy, and this is so you can grant cross-account access. It says, hey, allow that entity access to my account with the principal specified and no others. And then you have Neha's favorite, which is block public access, which restricts public access for all new buckets, if that's how you've configured it. And there's a lot of other controls, which we talked about. So these are something else that you need to collect, is how does AWS behave in certain scenarios under certain configurations. But you also need to collect those specific customer configurations. And these are the established controls that all of you set. So you might have a resource policy on an S3 access point that says only allow principals within my organization, the witches organization, because we're here tonight learning magic. Or you might have an IAM policy with conditions that says deny access to everyone outside my organization. And you might have turned on BPA because it's Neha's favorite and it's also a really great feature.
You should go turn on BPA.
Okay, we've heard it.
Okay.
Maybe. We might see it later.
Yeah.
All right.
Ooh. Okay.
All right, so you've collected your universal statement. You've collected your access controls. You've collected how the customer has set those access controls. So you have all this information, but how do you get to comprehensive? So to teach you that, I'm going to hand you off to Professor Neha for your transfiguration class.
Thank you, Bridget. Welcome, class, to Transfigurations 101. We're going to learn today how we turn AWS into math. This is the key. You will learn all the secrets in the next few minutes. So hold on to your seats. Now, I hope everyone's done their assigned reading. Yes, this is a class and there was assigned reading.
You did not tell me there was homework.
Oh, there's always homework, Bridget. Like, there's going to be a pop quiz. I know you like to have a good grade, so I'm sure you've studied.
Probably not.
Well, okay, I'm just kidding. But as you learn through this, you're like, if you want to know about the details, like, okay, how does it actually work? We have a technical paper that you can read how we actually encode AWS into math. So here's an example of a universal statement you may want to make about your environment. That you have a bucket, magic potions, that is only accessible from VPC broom or VPC wand. And at the bottom, you see a mathematical formula that represents this universal statement. And remember, a scientist calls it a property. So we're saying, hey, for this property to be true, I need to ensure that access is only allowed from VPC broom and VPC or VPC wand. So you see there's a mapping. It's using the same nouns and verbs that are in your English language universal statement. Now, I haven't told you about allowed. What is allowed? What is the definition of it? Access to what? This depends on the AWS control that you are evaluating this universal statement on. So let's look at that next. So here's an S3 bucket policy. We're also going to turn this into math.
I love policies.
And this is a simple bucket policy. You have an allow statement and a deny statement. So let's unpack how this turns into a math. The constructs within a statement are ANDed together. You have a string not equals, that's like a not. You have a list of VPC broom or VPC wand, and at least one statement has to match in an allow statement and ensure that no statements match a deny statement. These are basic semantics of policies. This is how you write policies. This is how you think of policies. Now, here's what the corresponding mathematical formula looks like. And if we start looking at it, there is a correspondence. It's like, oh, we are ANDing the different parts of a statement together. Here's the not. We had the string not equals. It shows up in the mathematical formula. Here's the or, and here's the part. The allowed is defined as we have to ensure statement 1 matches and statement 2 does not match, because that's the deny statement. It's not doing it across unquantified or all allows and denies, because we only have a single allow and a single deny statement here. So now we've turned this bucket policy into math. And for each of the constructs in the policy, we have a way of turning it into math. And that's when you can go see the paper that I pointed to earlier. You can go read the details on how we actually do that. So now that we have this formula that's turned into math, it represents the universe of possibilities. And turning this into the mathematical formula allows us to reason about infinite requests. So why does it mean infinite? So if you go back to your algebra class, when we talked about the proof of a real, like the square of real numbers being non-negative, we talked about R. Is there an R such that R is a real number whose square is non-negative? We are representing an infinite number of real numbers with a single value, a single symbolic value of R. That's the same intuition we are applying to the mathematical formula for what we have constructed from AWS. Symbols are representing many possible concrete values. So the mathematical formula for the bucket policy represents infinite number of requests that could come in. Infinite number of requests today, as well as infinite requests in the future. So that's how we're bringing the future here today. And just to show you, like here are the types of requests you could have that the policy takes in. Some will be denied, like if account 00 is calling S3 abort multi-part upload from VPC 0, it's going to be denied, but you have account 123 calling S3 get object from VPC broom, then it is going to be allowed. Now, here's a very few set of requests, but there is infinitely many number of requests that I could generate, and I wouldn't be able to fit them on the screen.
But you said you're a witch. Put them on the screen.
But that's the power of the math.
Okay.
The math puts them on the screen without me having to list them all.
All right.
And now we've created this AWS into math. It represents a universe of possibilities. Universe of possibilities for all possible configurations that can be accepted. Now, how do we actually solve them, right? Like, how do we do it? We have something called SMT solvers. Now, I'm going to provide a little intuition on what SMT is solved. And I'll step back for a moment to say what that means. Modern computing is a bunch of zeros and ones. The most complicated program that you could write can be represented as a bunch of zeros and ones. And the math of zeros and ones is called Boolean logic. So something we do in Boolean logic is solve them for satisfiability. Does there exist an assignment to the Boolean variables such that the formula becomes true? This is the problem of satisfiability checking. And if you, like, for small formulas, you could do it by hand. You could check it. But if you want to check formulas that have many variables, this is hard. It's actually NP complete. The universe of possibilities for a formula with about 20 variables is about 1 million. So with 30 variables, it's about 1 billion. So you see how that increases exponentially. And you need very clever algorithms and techniques to be able to find the solutions to them. That is what SAT solvers do. Now, we are humans, right? So if we do something well, we just end up going and making the problem harder. So we were like, okay, let's do SMT. So what does SMT do? It takes the Boolean variables and replaces them with richer types, strings, integers, more complex data structures. So each of the variables that was just a Boolean, 0 and 1, if now we've replaced it with a string, which you saw in the mathematical formula, because we were asking about things like VPC broom and VPC want. And these are not made up, like that's how we represent. We represent arms and we represent a lot of different values for VPCs as strings. So each of those variables now have a large universe of possibilities themselves. So that is what SMT solvers do. They take that large universe of possibilities and have clever algorithms to find solutions to them. So we have examples of open source SMT solvers such as Z3, CVC4, CVC5, and they have been, like, for the last 30 years, a lot of work has gone into them to make them efficient and be able to answer questions quickly. So great, we have all our things, right? So we've turned our universal statement into math. We've actually turned our bucket policy, our configuration into math. Now, here's a little trick. So I've talked a little bit about automated reasoning tools being clever, an SMT solver being clever. So how is it clever? It says, what is the result that I want to achieve? And the result they want to achieve is quickly find you, I would call it a counterexample or something that says, here's why your universal statement is not true. If it finds an example like that, it's done, right? So it uses that trick to search across the space quickly. So to help the solver, what we do is we negate the property. The property is this holds, so we say assert not the property. It's asking, does there exist a request that the policy accepts that violates the universal statement? And if the solver finds a path, that means the universal statement is violated. And we have to go fix either the policy Or maybe we are not even asking the right question, so there's two possibilities. And then we give it to the solver again, and we iterate until it says, no path found, I'm done. And at that point, you know that the policy satisfies that universal statement. So we're going to see a real quick demo on how the solver works through it. It is like magic, but like as Arthur C. Clarke once said, any advanced technology seems close to magic. So it is one of those things.
Ready?
Yep.
Okay, the first one's a video. Solver magic.
So here's the example policy that's transformed into math. You have the first statement, which is your allow statement, the one we were looking at. We have the second statement, which was the deny statement. And here we have the universal statement also encoded into math. So we put this in a file and runs the solver. We are going to run a solver called CVC4 and see what's the result we get. Oh, it failed. It says principal 1, 2, 3 can perform the get object action on the magic potion button from VPC broom. But why has it failed? We looked at our universal statement, and instead of VPC broom, we said VPC potion. We got our universal statement wrong. So we're going to fix it and run it again. And there it says unsat. Unsat is the equivalent of no path found. I know now that the universal statement holds for all possible requests that the policy can accept. Now, this is not magic.
It's just
math.
Took me a few years to learn that.
So, to recap, we collected our AWS controls, our universal statements, all the possible values. We turned AWS into math that represented the universe of possibilities. We gave it to solvers to quickly find answers. And when we did, we had comprehensive, provable answers in the correctness of our security. So, Bridget is going to tell you what are we going to do with all the things we've learned in class.
All right. So you've learned the foundations. You've got the basics. You all got it right, 100%. OK. Awesome. We're going to brew some more comprehensive potions. And what do we mean by more comprehensive? So when it comes to advanced automated reasoning, you want to be able to ask more complex questions. You want to be able to solve with speed, and you want to be able to solve at scale. These are all things that we've had to do as we've powered AWS with automated reasoning. So more complex questions. You might want to say, my KMS keys are only accessed from inside my organization. Or my bucket is not shared beyond my account. And more on the way. And so what do we do when we have more questions? And you might have a really specific question that you want to ask, like, does Pickles have cross-account access to the Apple bucket? Because Pickles is a horse and he loves apples. But before we do this, if you have multiple configurations, you got to break it down. And so how do we break it down? We break it down into different questions that then we use and send back through all the things that you just learned. So we say, does the resource policy grant public access? Because if it's public, then Pickles can surely get to the Apple bucket. If the access point policy grants public access, same thing here. If Pickles has admin access to the Apple bucket, then he can probably eat the apples. And can Pickles eat the access? Does he have eat access to the Apple bucket? Now, there's no new S3 action called eat, but I thought it was funny for today. And so we break it down into 4 parts, and what do we do with it? We do what you learned, right? We collect the resources. We take the universal statement, we collect the controls, whether it's an access point policy or a bucket policy, and how have you set them? Do you have BPA turned on, et cetera? And we run it through the same thing. And we take those 4 provable answers and we do some business logic. If any one of these are true, then Pickles does have access to eat those apples. And if he doesn't, then we can also, say other things about it if we found something. But if he does have access, and we also found it to be true that there's public access, then we can also share that with you, which might be really important. And so that's how we make more complex questions. But how do we solve with speed?
So given that we are asking more complex questions, by decomposing them into more questions. And for that, as Bridget said, we need to be able to solve quickly. And our approach is something called using a portfolio solver. So different solvers have different superpowers. They are better at certain theories, certain logic. So we use a set of solvers in the back end, and we send the query in parallel to each of them. So that's why it's a portfolio. And with the winner-take-all strategy, we return the answer that the solver returns first. Because if somebody is really good at analyzing a certain type of string query, it's going to return very quickly. And so we leverage this diversity amongst SMT solvers in this portfolio solving approach to be able to answer lots of different questions quickly for all AWS customers, including those of Pickles.
That's right. I like this mode of using the SMT superpower. I think that really works out for us. Helps each one play to their strengths.
Yes.
Okay, cool.
Now, people are saying, you've been talking a lot about this magic, right? And they're like, but I've never heard of it. Why haven't I heard of automated reasoning? Like, if it's all this great, all of those things, that's a very valid question. So here's why it's been hard in the past to apply automated reasoning. When I've talked a lot about universal statement, but where do these come from? Somebody has to write them. Somebody has to think through them. And as we saw in the demo, it's almost as hard to get the universal statement right as it is to get the actual configuration right. So there's this tension. If not asked the right question, your answer's going to be wrong because you've not asked the right question. You want to know, how do I get to the Venetian? But you've asked, how do I get to Venice? And now the answers you got are very different. So this has always been a bottleneck for automated reasoning because it's required experts to ask the question. And they have to have an understanding of the underlying tools, the automated reasoning tools, to ask the question. And at AWS, we were like, we need to innovate this because we want all AWS customers to be using it. So we flipped it on its head. We made the automated reasoning engine responsible for coming up with the universal statement. So Bridget's going to show you this demo in a little bit, but I'm going to give you a little peek behind the curtain before that. In Access Analyzer, we give the automated reasoning engine a policy, and it gives you a set of findings. What are these set of findings? These are declarative statements about what is true of your policy. Each of them is a universal statement about your policy. It'll say, Nick has access to this bucket. It'll say, Bridget does not have access to this bucket. And then the reviewer, who's going to come and see the policy, can say, yes, this is intended. No, this is not. I'm going to fix it. But now you see, I've reduced this burden. It's simple for the user. We've created abstractions. We've created a flow that can just, for customers, can be using this thing without ever having to even come up with a universal statement. And this has what has allowed us to reach the scale where we are now running 1 billion SMT queries a day. And it is day one. It's still day one. There's a lot of different problems. We're just getting started. And there's a blog post about it. You can search for it and read about how we got to 1 billion queries a day.
Yeah, we talk a lot about like, what else can we do? Okay, so you have learned the foundations of automated reasoning. You've learned the foundations of how this magic actually works and that it's actually math. But have you used it yet? How are you going to use it? Well, I'm going to ask the audience a question. How many of you have used IAM Access Analyzer, specifically the findings part? Okay, there's a few hands. My previous coworker did not raise his hand. All right. And then how many of you have used block public access? Okay, a few hands. There we go. Neha's favorite. And then what about network access analyzer or reachability analyzer? There we go. Got some network folks in the audience. That's great. Okay, congratulations. You are already using automated reasoning because all of those features are powered by automated reasoning. And that's what we did in AWS, is we brought automated reasoning to you through managed services like Access Analyzer, Network Access Analyzer, and Block Public Access. So these are your security charms. These are the charms you get to take back. So this is the point of the talk where I'll be doing some demos. It's also the point of the talk where I want you to break out your magic wands if you happen to have them stored in your backpack somewhere. No, you don't. Okay. All right. So our first charm is show me public access. And with IAM Access Analyzer, you can review public findings for 14 resource types. This is new. It used to be a lower number. It is now 14. You can enable IAM Access Analyzer in your account or your organization. It's a few clicks, free of charge. I highly recommend you go and enable it. What it does is it continuously monitors and reviews your access controls across those 14 resource types. And we're not just talking policies here. We're talking all the access controls related to that resource type. It uses automated reasoning, all the things you learned today, to determine if they're public and cross-account access. In your head, you should be thinking, ooh, that's my universal statement, got that. Then it generates findings for you, and you can review, see if it's intended, and then you can verify. So our first demo is we're going to figure out which buckets of mine are public, and is there a path to public. So just to prep, I did enable IAM Access Analyzer, and it has been running in my account for probably a long time now. And we're going to go look at some stuff. So I'm going to flip over to my computer, and I'm doing it live, so if I mess up, no shame. Okay. Oh.
Not yet.
Not yet. Maybe I need to log in first because it went to sleep. There we go. First step.
Oh, we're there now.
Alrighty. So this is a test account I have in my organization. And you can see my buckets here.
Do you have anything that's public, Bridget?
It actually made me a little nervous to create a public bucket, but I did.
You have a public bucket?
I do. But it's got pictures of pickles in it.
Oh, so it was intentional.
It was totally intentional
Okay.
because I want everyone to see it.
Okay,
So
awesome.
you can see my buckets here. I've got pickles treats for all. I've got some Oreos, got some carrots, got some apples. You know, keep the treat theme going. And if we click on this, you will see all the pictures of pickles. We can look at those later. Don't have BPA turned on. Oops. And I have a very, very public policy attached to my bucket. Okay, so our security charm is show me public. So navigate over to the IAM console.
But before that, like, if I want to mark a finding intentional, what do I do?
Oh, I'm not even at the finding yet, so hold on.
Oh, okay.
Okay, so here are all my findings. I'm at Access Analyzer, and you can see I have some cross-account findings because I have shared those other buckets with other accounts. But I want to look for the public ones. And this is public access, and I'm going to say true. And there is my bucket. It is very, very public.
That it looks very public.
Yeah.
All principles.
But it is intentional, so it's
Right.
okay.
Okay.
Because it's pictures
Okay.
of pickles. Right. If I wanted to mark it as intentional, which I'm not going to do because we have some other fun stuff to show you, I would go and look at my archive rules, or I would create an archive rule. I already have a few archive rules, and these are all the trusted security counts in AWS and all of that. And so you can see that I have some roles that are trusted and whatnot, and I've archived them because I'm marking them intentional. I have not addressed the other cross-account ones yet. I will definitely
Okay,
do
but everyone should get to 0 findings.
that. Is true.
0 findings. So either you fix your finding or mark it or create an
Is that
archive
homework?
rule.
Are you signing homework now?
Yes,
Okay.
yes, because it's security. That's how we get to a universal statement.
All right, can we get on the demo?
Yes, yes.
All right, so you have just learned a security charm. You have show me public access. All right, next one. Everybody wants to know the future. Show me the future. Wouldn't it be great to know the future? Well, if you listened to Neha earlier, she said it's not only the current scenarios, but all future scenarios. So with IAM Access Analyzer, you can also see how policy updates can change the future. So you can verify your policy change before you make it. And so I'm going to go back to a few of my buckets, and I'm going to play around and see if I can resolve my public access. I might also try to create some public access and see how it changes my future.
That sounds futuristic.
It's just math.
Okay.
Okay, so I am over at my bucket, and I'm going to edit it right here. So remember, this was public. And I've kind of decided I want everyone to see pictures of pickles, so I'm going to add a condition and to just make it within my organization. And I'm going to copy paste this so you all don't have to watch me create a typo. Okay, and I'm going to go to Preview External Access over here. It uses my analyzer within the account that I already have set up, so that is a requirement. And I'm going to preview.
So what if there was a typo? Would Access Analyzer tell me?
Yeah, it would show up actually in the security errors and warnings. If it was a typo, probably errors. If you did something that you didn't want to do, it was probably security. So definitely check those out. And you can see down here that it has resolved my public finding. And that's great, because I didn't want it to be public anymore, but it actually created a new finding that says all principals have read access with a condition. And I can open it up and it says, okay, principal org path. Okay, so all principals in my org now have access. Now I can save these changes. Now I still don't have BPA turned on, just wanted to note that. And I can go over to the finding that is here. I'm going to open it up again. And remember, it's still active, but I'm going to rescan it, and I'm going to see if I've resolved this finding. And I have. I've remediated my public finding by putting an org condition on it. It would also generate a new finding because I looked into the future, but at least I got rid of my public. Now, the other thing you can do is go to the other bucket, the Apple bucket maybe, and you can try to make something public. Now here I have a lot of shared with a lot of other accounts. That's for actually another demo. And I'm going to try to make this public. Oops. There we go. Don't worry, I'm not going to save it. I'm going to preview external access again. And here you should actually see all my cross-account access resolved, but a new one created once it pops up. And so this is how you can change policies. This is also available via the API, so you can look at stuff. And here you can see all of my cross-account was actually resolved because I removed all those other accounts, but I have a new public one. And I don't really want to do that, so I am going to cancel that real fast. Okay.
Phew, no public.
We looked into the future. Who's ready for the next charm? What do you think it is? Their favorite. Yes! All right, the next charm is block public access. So you can enable BPA on Amazon in your account or on a specific bucket. It restricts access to an access point or bucket policy that grants public access. One way to think about it is there's two ways. Either the existing access or just any new thing that grants public access. And so when you do the new thing, it actually rejects calls to an access point policy or bucket point policy if the specified policy is public. And that's actually what I'm going to demo here today. So I'm going to enable block public access to all my buckets. So even if the pickles one was still public, it would block it. And I'm going to edit the bucket policy to see if I can create a new public policy. Okay, here we go. All right, so I'm back in my account. I have BPA off. I'm going to edit it. I'm going to turn all those settings on. So I do not want any public anymore. I have changed my mind. I'm confirming this change.
Wow, that was easy.
Yeah.
Simple.
That's why you like it. I am going to go to, I'll go back to this public one, and I'm going to just remove that, try to remove that condition. I'm going to edit this policy, and, okay. So this was my public bucket. I put the condition on, made it unpublic. Well, now I'm going to try to make it public again, and I'm going to try to save these changes. But now I have BPA turned on, and I can't do it. I didn't change my human permissions trying to do this. I can't do it. It gave me access denied. Why? Why? Why did it do it?
We turned on BPA.
We did.
And you see there's a warning on top as well. It says public access is blocked. So it's, even as you're editing, it's telling you, but the preventative control is down top.
I can't do it.
Down at the bottom.
So even if somebody wrote a script
to
do it. Okay. All right, so that was pretty fun. I'm going to cancel this out. I'm going to keep my policy as is. All right, we have one more for you today. And this is going over into networking land. So tell me who can talk to the internet. So we are going to use VPC Network Access Analyzer to review network configurations. If you haven't played around with this, it helps you identify unintended network access relative to your security and compliance requirements. It helps you verify the internet accessibility, network segmentation, trusted networks path, trusted network access. What I love about this, because I live in permissions land, not in network land, it comes with 4 purpose-built network scopes. And so you can go over there and just click Analyze, and you will see who can talk to the internet. And you can use it in the console or API. So I have some internet gateways set up, some subnets, some instances using TCP and all that jazz. And I'm just going to show you around. I've already clicked Analyze. It's really easy to do. Just go over to the console and click Analyze. And I'm going to actually change over to my dev account because I have everything separated. So this is a different account, still within my organization. And here are the 4 default network scopes. And I had already clicked Analyze. And you can see over here that it says Findings Detected. So I'm actually going to click on the ingress one to see what can come in. And you can see the start is at the Pickles Internet Gateway, and then the end is the Pickles instance. And you can get all of these details about the port and what's there and all of that. And then I really like this over here. It kind of breaks it down and makes it easy to follow. The other one you can do, which also had a finding, was on, and I very intentionally created these findings, by the way, for the demo, was the egress. And same thing here with the Pickles instance and out to the Pickles Internet Gateway. There we go. So you can use this. You can create your own scope. So if you're really curious about something, you can specify. And then actually, as I was debugging this example, I used Reachability Analyzer. And so I was able to put in things, and it would tell me why it wasn't reachable or when it was reachable. So that was really helpful along the way as well. So go check it out. All right, so those are your security charms. Show me public, we can show cross-account, we can block public access, who can talk to the internet, who can the internet talk to, what else? What's coming?
So we're using automated reasoning across a lot of things. So you've seen a few things, but there's this shared responsibility model in security, and we are applying a lot of automated reasoning internally to prove correctness of the boot code running in our data centers, to prove the correctness of protocols in cryptographic protocols. We are using it to prove correctness of some of the most critical systems, including authorization, storage, and we are powering a lot of external services, some of which you've learned about, and we are providing what we believe is a transformative experience for our customers when it comes to the security, because we are providing the highest level of assurance that is possible for the security of their cloud configurations. And this is day one. We are just getting started. So yesterday, we launched in preview Amazon verified permissions. So if you're building applications that you want to configure your own custom resources, create permissions for those, you can go check out Amazon verified permissions that we've learned from our experience and from running IAM and have provided this capability for customers using the foundations of automated reasoning to there. So I would go check it out. It's available now.
Awesome. I'm pretty excited for that and what it can do for access control in applications. And if you want to learn more about everything you have learned today, you can check out our favorite Security Alchemy resources. The deep dive in IAM Access Analyzer, that was actually when we launched the service, but it goes into a lot of the automated reasoning aspects. If you haven't heard enough of Neha and you want to hear some more, achieve the highest levels of security assurance with provable security. That was a great talk that she gave a lot of people, resonated with a lot of people. Same thing with the blog posts, how we use automated reasoning to help achieve security at scale. And then the provable security page on the AWS marketing site, we always keep it up to date with latest resources. And so you're going to see videos and also the science blogs and also any of the services that use automated reasoning in AWS. Thank you all for coming. It was so much fun to be here with you tonight. It was really fun to talk about automated reasoning and security together. Thanks, Neha, for being
thanks to Bridget. We had a lot of fun. I hope you did too. But please go fill out the speaker survey. We always love hearing feedback, and that's how we decide what to,
We do look at the feedback,
yes.
every piece of it. We will be taking some questions off stage and once we kind of close up. Thank you very much, and enjoy your reInvent.